Alright, so today we're going to start with a liquid damaged unibody that somebody donated here, which is very nice of them. They just went up and said, you know, I have too much money, and since I have too much money, I just kind of want to give this away instead of selling it for $100, even though I don't really need a new computer. And so when we turn it on, there's an image on the screen, which you'll never see with this shitty camcorder, but I can, but there's no backlight. So let's go about troubleshooting this circuit. Now I've said that if you want to find a short in the backlight circuit, you can start from the capacitor or the diode on the other side of the board, from the backlight output to grounds in diode mode, or you can check with resistance. I prefer diode mode, and you can see what measurement you get. That was what I discussed in the prior video. On this one, I'm just going to start from the top because the board is still screwed in, and honestly I just don't feel like taking it out right now or probing on the LVDS connector. So first thing I'm going to do is check the fuse. There is a fuse for a 12 volt, here we go, where 12 volts goes through before it gets anywhere else in the circuit. And that's this little thing with a dot on it that looks like shit because this was liquid damaged or something, or piston or whatever. See that little thing with the dot on it? I'm going to point to it for you guys who are blind. You can't see. I actually kind of like using the oscilloscope just because I have these little shitty alligator clips to them, so I don't have to hold both, and my probe is much smaller. So I wind up using this a lot, even though the multimeter will clearly do the job. So on both sides of my fuse, I have 12 volts and 12 volts. So the fuse is good. And the connector itself looks fine. It's not blown up, you know, even though it looks like shit cock and balls. So the next thing I'm going to do is check backlight enable. A couple of things that you check in the backlight circuit is physical damage, like a broken LVDS connector, blown fuse, usually because something in there is shorting the ground, or there's something wrong with the basic circuit that tells it to turn on. So here you can see the backlight circuit, and here you see BKLEN. Over here, there's supposed to be 3 volts, but there is no 3 volts here, as I'm going to show you. Now the way this works is, you see LCD backlit power, backlit power. So that is going to be 12 volts, and there is a FET on the other side that's going to switch that on. Now R9731 and R9715 is a voltage divider network that's going to turn that 12 volts into 3 volts. So let's see what we get here. Now R9715 and R9731, according to this thing here, let's plug in and see what we get. R9731, R9715. By the way, if you're going to bitch about the camera angle, how about you pay me so that I can hire a fucking assistant to stand here and be my cameraman? Thank you very much. Okay, let's see what we find. Alright, so it says that it's these two right here. So, let's see what we get. Now, one of those, remember, I'm supposed to be getting 12 volts from, because that's going from 12 volts to the input of backlight enable. And as you can see, I do get that 12 volts. So there's a FET on the other side of the board. I believe it's on the other side of the board on this one. I honestly don't even remember off the top of my head. That there's a FET on the other side of the board that says whether or not to send the 12 volts over here or not, so that I don't have to look through that one because it already works. That FET was actually the problem in the prior video. There's a fucking solder blob on it. On the other side of this, I have nothing, so that's the end that's going there. Now, a voltage divider circuit is going to be one resistor that goes from the voltage you want to lower to its destination, and then from the destination to ground. And that's going to do the voltage dividing. So let's see. Now, that other resistor in the network, one of them is 301K, and one of them is, let's see, I'm actually looking through the viewfinder, and I can't see shit in this fucking shitty viewfinder. One of them is 100K. There we go. Oh, I can't believe how shitty this viewfinder is. Alright. So I'm going to try measuring them now. And in order to try and measure it, I got to put this in the tripod so you can see, because I do need both hands for this. I'm spinning this the wrong way here, and I fucking genius. Alright. Okay, here we go. Get this. By the way, if you want to measure the resistance of something, make sure to turn the shit off. I'm booting off of a drive with bad sectors that I used to test shit, so I don't give a fuck that I'm not turning it off properly because it's already fucked. That's why I use it as my test drive, so I can abuse it. So, obviously, turn everything off. Do not try to measure resistance with shit on. It just is don't do stupid shit. Don't be lazy. Alright, so the first resistor.
Yeah. Oh, don't worry. I'll just tell this one. You remember this? I remember.
That did not work when he brought it in. It was flashing and blinking and booping and bopping and...
I'll leave it on. I'll leave it play with you. I'll just tell him that. No, I'll firm mark you.
I'll firm mark.
You don't want to kill that shit.
If you firm mark that, it's gonna die.
That's what I'm saying, dude.
Just
leave it on. Play like a YouTube video or some shit.
Dude, if you play a YouTube video, it's gonna die.
Play a YouTube video.
Make sure it's 360p or less. Play the Honeymooners. That smells worse.
No, that smells good.
That smells worse than GPU soldering. That smells 10 times worse than GPU soldering. Good. So this over here is supposed to be. It is really sad how not steady my hands are. I have to get smaller probes for this fucking thing. You could see I go through probes like crazy. I wind up bending them or destroying them. So this measures 106 kilo ohms. And this measures 17 and counting kilo ohms. And they're supposed to be 301K and 100K, which means that this is fucked and needs to go. Okay, let's get started. Alright, so I'm putting this captain tape here because I know that I'm going to wind up burning the LVDS connector. Manera, it's 60 plus tax and give her the protector. But also read the notes. Manera, make sure to read the notes. Bye. You read the notes, Veneer? I said that you read the notes, Veneer? Oh, then Veneer, then make Steve read the notes. Huh? Excellent. Okay, so I left solder on the tip of my iron, which actually just came off and burned my finger. I'm a fucking idiot. And I can't see, because I'm soldering through the viewfinder of a $100 camera. I can't see shit. So now I have to find the 100 and the 301 kilo ohm resistor. Alright, so I have another board here that has the 101 and 301 kilo ohm resistor, which is close enough for this shit. I'm gonna eventually wind up getting one of those cameras that you could put inside the microscope so that I can actually see what I'm doing. Because not only can I not do this in the microscope in order for you to see it in the camera, but I actually have to use the camera as my as a microscope, and that's really awful. Okay, just refill it so that they're actually straight. Okay, you ready to see sparks? Fire? Excitement? Let's give it back. Okay, back to the moment of truth. Then we're done. And if I point to it on the oscilloscope, which, oh god, I'm trying to move the camera while keeping the probe on there. And this is failing. Oh, this is failing. Alright, let's just take it off the tripod. See? 2 volts, 2.8, it really doesn't matter as long as there's something there other than 0. Here we have 2.8, and we're good.